All right, advent of code day 6. Today's problem is it's kind of the opposite of the previous day, where our parsing is actually very easy, but the algorithm is just a little bit tricky if you want to do it in the most general way. So all we're really doing is we're receiving a string as our input, and we want to find the index of the first place where the previous 4 characters were all unique. So let's go through the string. We have M, J, Q, J. So these are not unique because they're 2 J's. So we have to skip ahead to, Q, J, P, Q, 2 Q. So that's not unique. But then once we have J, P, Q, M, these are 4 unique characters. So we want to return the index of this M, which I think it's like 7. Well, starting from 1. So 1, 2, 3, 4, 5, 6, 7 is the value that we would return in this case. It gives a few other examples. And then the only thing that changes in part 2 is that we need the previous 14 characters to be distinct. So this isn't too complicated, but there are a couple of different ways to approach it. The first way I approached it, I didn't really end up liking because it didn't scale that well to the second part, because I just made a data type where it's like, okay, I'm going to track the 3 characters as atoms, as sort of these single values. And then for the second part, I had to modify that data type to instead have 14 different characters, which was like, it worked, but it's kind of like ugly. So I ended up rewriting my solution to look a little nicer. And the way to do this is we have a map that stores the number of characters that we've seen in our previous X for whatever X is. And then we also just store those characters in a sequence, the characters that we've seen, so that we can drop the first and add a new one onto the back. So that's the approach I chose for my sort of revised solution. So one utility that I haven't used yet in 2022 that I'm going to use now is the occurrence map. So occurrence map, we just are counting the number of a particular item. In this problem, we're going to be counting the number of occurrences of particular characters. I have a few different varieties of occurrence maps. I found this to be a useful abstraction that came in handy for a lot of last year's problems. So we'll be using that. So it just exposes some helpful APIs like increment key, so that we bump up the number of occurrences for one of our keys, and also decrement key. And an important thing with decrementing the key is that if we are ultimately going to reduce it to be 0, we want to delete it from our map. That feature of this is actually very important because it makes our check for distinctness is going to be a lot easier that way. So now let's get into the day 6 code itself. So our parser is basically trivial. We just get a bunch of letter characters and we're parsing a string. Nothing complicated there. So now the heart of this algorithm is this function, process chars, and it's just going to be parameterized by the number of characters we need, so that we can apply the same function to part 1, part 2. Part 1 is just going to use 4 as the number of characters we need. Part 2 just uses 14. So what do? First, we have to split our input. So we split at the index number chars needed -1, so that we get the first characters and then the rest. Obviously, we'll just sort of log an error if we don't have enough characters, because that's kind of invalid. But then we have this split, so we have our first characters, we have the rest of the string. Now we'll make our sequence, so this is the queue that we're going to store these characters in, and then we will also make our occurrence map. So this map stores the number of times we've seen each of these characters, and we'll see how that plays out in our recursive helper function. So process tail, again, parameterized by the number of characters needed. Again, has a base case where if we just don't have enough data and we haven't found anything unique, then we just log an error and return the maximum number. But what do we actually do in this function? Well, assuming that we actually have characters in our sequence, so assuming we get here, we have the first element, we have the rest. So we're going to increment our occurrence map based on the first character that we're seeing. So first, this is the first character in the remainder of the list. So remember, base case is empty string is remaining. So our recursive case, we have at least one character in the string, and we're incrementing the occurrence of that particular key. Now, we want to check the size of our occurrence map. We should have an invariant at this point that the sum of the number of occurrences should always be 14 at this point. And so what we're going to check is, okay, is the size of our occurrence map equal to, or not 14, but just the number of characters we need, whether that is 4 or 14. And so if that size is equal to the number of characters we need, what we expect is that we have 14 unique characters in our map, and so we are done. So we return this count value, another value we're just sort of storing in this recursive helper. If that is not the case, if we have not met our criteria yet, what needs to happen, we need to increment our count so that the final index we return within the string, we have to bump that up by 1. We're also going to take the remainder of our sequence. Remember, we are dropping the first character from the sequence. We're going to add the new character onto the remainder of the sequence, and we're also going to decrement the key. So we're going to remove one instance of that first character. So this is why we need the sequence. We need to know which one is getting decremented. So we decrement that key, and now, so after we apply this, I shouldn't say that the invariant is 14 or 4. At this point now, the sum of all the occurrences in our occurrence map should be 3 or 13. And so we'll just do a recursive call. So entering the function, it's 3 or 13. At this particular point when we're doing the check, it's 14 because of this increment key call. But we just recurse until we reach, the point where our condition is met, or we're at the end of the string and we have effectively our error case. And that's basically it. That's there's not much else to this problem. So I did, of course, write some tests for this that they should all still be passing. But we'll just see we get our answers. I can actually show you the tests right here. So first case, 7, 16, 55, 19, etc. So that is what we have. That is all for our day 6 code. I will be back again tomorrow with day 7. So stay tuned for that. Make sure to subscribe to the Monday morning Haskell mailing list if you are enjoying this content so that you stay up to date with everything we're doing on the blog. So thank you for listening and see you tomorrow.